Number 57. Write the resonance forms of ozone, which is O3, and it's the component of the upper atmosphere that protects the Earth from ultraviolet radiation. All right, so remember, guys, that resonance always comes from knowing how to draw Lewis structures. So I can't stress this enough. If you guys don't feel strong in your Lewis structures, go back to questions 40 through 45 of this chapter. I'm there with you guys every step of the way, and I do those problems for you if you haven't done that already. If you have, you should be good for this question, and we will start from there. So I'm going to assume that you guys know how to do your Lewis structures. I'll give a little help along the way, but this one is more dealing about resonance forms. So the first thing you have to do is you have to draw the correct Lewis structure for O3. So it looks like I just have 3 oxygens in a row. So I'm going to say oxygen, oxygen, oxygen. And remember that oxygen has a total of 6 valence electrons, 6 electrons in the outermost shell. So at the end of the day, if there's 3 oxygens, right, you should have 6 times 3, which is 18 valence electrons at the end. So that's like a little, test that you guys can do at the end to see if you have the right structure. Now I'm going to draw the Lewis structure here, and you see if it matches up. So if you want to do your own Lewis structure, pause the video and see if it comes out like the one I'm going to draw. So you should have a double bond on one end. Now it doesn't matter which one you put. I'm going to put it on the left-hand side, and I'm going to draw the single bond on this side. So if you swap them, that's fine too. And just know that the oxygen all the way on the left has 2 lone electrons. The oxygen in the middle should have 1, and the oxygen all the way on the right should have 3 pairs, or 6 electrons. And if we count them, we're looking for that 18 total, right? So 2, 4, 6, 8, 10, 12, 14, 16, 18, and there you go. So now I need to have a resonance structure for this compound, which is ozone, O3. So whenever we draw resonance structures, we bracket them off, and we put a little arrow there, meaning that any compound with resonance will always flip back and forth and back and forth and back and forth between the X amount of resonance structures that are in the compound. So ozone, for example, ozone, this guy, is not going to stay exactly like this compound. It will flip-flop between that one and the one we're going to draw. They're not stagnant. But the key thing in Lewis structures and with resonance is the backbone has to stay exactly the same. But in this case, it's just 3 oxygens. So, you can't really change that. But if there were different elements, you have to keep the same structure within them. So, now let's see what we can do. Well, you can either start with a lone pair, or you can start with a single bond, right? I'm going to focus on this bond right here. So remember that one line just represents 2 electrons, right? So if I pull this out and I say that that is 2 electrons that are being shared, I'm going to try to see if I can just redistribute the electrons to make sure that the octet rule remains intact. And that's all that resonance is. All you're doing is you're shifting electrons, but keeping the octet rule. And the octet rule states that most electrons want to have that 8 total valence electrons. There are exceptions, but for oxygen, he wants to have 8. So now we're over here, right? So where could this lone pair go? Well, it could either go here, or it could go to the oxygen all the way at the left. Now, if it goes to the oxygen all the way at the left, this oxygen is still going to have the octet rule. 2, 4, 6, 8 electrons. So that's following the octet rule. But look at this oxygen, though. 2, 4, 6. It doesn't have the octet rule, right? Because it only has 6 and not 8. But look what the oxygen on the right-hand side could do. Just like these electrons just like these electrons were taken out of a bond, these electrons can be put into a bond. And two electrons that are being put into a bond, they're now sharing. So that is now a double bond. And do you see how you just shifted the double bonds? That's all that resonance is. But I just wanted to show you guys, what is literally happening. So I'm just going to erase all this. Uh-oh. I don't want to erase too much. So I'll just erase from here then. And put this back. Okay. So all you're basically doing is you're taking the double bond that was on the left side and putting it here. And you're just making sure that you have the octet rule. So I'm going to say that this turned into a single bond, and this is now the double bond. And you just put your lone electrons. So this wasn't touched. Now this one has 3 pairs, a total of 6 to make the octet, and this now only needs 2 pairs to fill in the octet, because this oxygen would have 2, 4, 6, 8. And there you go. One last thing that I want to say. Some students might say, hey, well, what about if we just add a bond here and get rid of this? You can't do that, because then you won't have... Actually, you actually can't do that, because then this oxygen will have more than 8. 2, 4, 6, 8, 10. But even still, we can try to manipulate it so that I get rid of this and put a double bond, right? But even still, this oxygen will have 2, 4, 6, 8, 10. And that's not good. Oxygen is not below the second period, so therefore it cannot have an expanded octet. So we are done. So I just bracket it off. And that means that ozone only has 2 resonance structures, and they will flip-flop between the structure on the left and the structure on the right, back and forth and back and forth and back and forth all day long. And that's that. So make sure you know your Lewis structures, and then from there, you can get into your resonance structures. Super important for when you're taking organic. If you are, let me know if you are in the comments. But as far as this one, 57 is done. So thank you so much, guys. If you want to click subscribe. If this video helped you at all, let me know in the comments. I thank you for that, and I will see you guys in the next question. Bye-bye.